We're given a geometric series. So the sum from n equals 0 to infinity of 9/4 times 1 over 4 to the n. And I want to plot the sequence of partial sums. And then we want to use the graph to estimate the sum of the infinite series, then confirm your answer analytically. Okay, so the partial sum, we can write that as S sub n. So this is the sum of the first n terms. Basically, I guess I'm going to change the notation. We'll call it S sub k. So we'll go from n equals 0 to k minus 1. 9/4 times 1/4 to the k. Okay, so this is the sum of the first k terms. And because it's a geometric series, we know that it's going to be the first term minus the omitted term over 1 minus the ratio. So if I want to add up the first n, the first term will be when n is 0. Okay. If I plug in n equals 0, I get 9/4 times 1/4 to the 0 power. The nth term will be when this is n minus 1. Okay, because when n is 0, this is your first term. When n is 1, that's your second term. So do you see how you have to add 1 to the n? So if you're looking for your nth, if you're looking for your nth term, n here is n minus 1. Okay, so look at the difference here. The difference is always 1. Okay. So the omitted term will be the term after the nth term. So that would be the n plus first term. Okay, so that will be plugging in n to our formula. Okay, and then the ratio is whatever is inside the parentheses, which in this case is 1 over 4. Now we're going to simplify. 1/4 to the 0 is just 1, so that leaves us with 9/4. And we have minus 9/4 times 1/4 to the n. And that's going to be all over 3/4. The nice thing is that they all have a 4 in the denominator, so I can multiply top and bottom by 4, and that's going to cancel the denominators. So that simplifies to 9 minus 9 times 1/4 to the n, and you can also factor out a 9, which will be 1 minus 1/4 to the n. Okay, so this is your partial sum. Now we want to graph this. So if we say, when n is 1, you get 9 times 1 minus 1/4. So it's 9 times 3/4, which is 27 over 4, which is roughly, it's exactly 6.25. If we let n be 2, that would be 1 minus 1/4 squared. So 1/4 squared is 1 over 16. Subtract that by 1, it's 15 over 16. So this one, it's kind of hard to simplify, so let's see. You end up getting 8.4375. Keep going. Let's look at S sub 3. That'd be 1/4 cubed. 1/4 cubed is 1 over 64. So that'll be 63 over 64. That'd be 9 times 63 over 64 is 8.859375. So if you continue this further, it's quite obvious that this number in here is getting closer and closer to 1. Okay, so really, if you look at the limit as n approaches infinity of s sub n, it's just going to be 9. Okay, because this number, the 1 minus 1/4 to the n, I guess I can write this out. I can factor out the 9, and 1/4 to the n is going to go to 0. So this is really 9 times limit as n approaches infinity of 1, which is just 1. So 9 times 1 is 9. Okay, so this is going to be the infinite sum of our series, and they did ask us to graph it. So well, he said when n was 1, we got 6.25. When n was 2, we got 8.4375. N was 3, we got 8.859375. And so as you graph this, you'll get closer and closer to 9. Okay, so 9, you can think of 9 as like your limit. So like 4 will be closer, etc.